Here's a quick introduction to Chapter 2, where the main topic is linear combinations. Now, this is actually something we have seen already, but now we're going to have some new words to put to it. So here's the definition. If you're given several vectors, x, y, z, w, a linear combination is choosing scalar multipliers, c1, c2, c3, for each of them, and then adding them up, just like this. Multiply by the constants, and then add up the results. So we have seen this already. A system of linear equations with constant term can be described as a linear combination of the coefficient vectors with variable multipliers. Like if you have this system x1 plus 2x2 minus 3x3 equals 5, then 2x1 plus 4x3 equals 2, then the system is x1 times the vector of coefficients 1, 2, plus x2 times the vector of coefficients 2, 0, since there's no x2 in the second equation there, and x3 times the vector -3, 4, and it equals the vector 5, 2. So we call this a vector equation. In this case, it's an affine vector equation because it has a non-zero constant, and the linear combination is the left-hand side of that equation. We also saw it as a way of writing the general solution of a linear equation, a system of linear equations with a free variable. For instance, we'll just go ahead and solve this one for practice. 1, 2, -3, 5, and 2, 0, 4, 2 is row equivalent to 1, 2, -3, 5, and subtracting 2 of that first row from the second row, we get a -0 and a -4. And then subtracting 2 of -3 means adding 6. So you get 10 and -8. And then divide that second row by -4. And then go ahead and subtract 2 of that from the first row. And we end up with 1, 0, 2, 0, 1, -5 halves, and 1 and 2. And now that's in reduced row echelon form. Definitely go back and do it without looking to see if you can get the same answer. And once it's in reduced row echelon form, we put it back into the equations. So x1 plus 2x3 equals 1, x2 minus 5 halves x3 equals 2, and x3 is a free variable because it's not a pivot. I solved that for x1, x2, and x3 so I can see how the free variable is in the formulas for the others. And then I can write it as a linear combination because now I can write the coefficients of the free variables as a vector. It's x3 and the coefficients are -2, 5 halves, and 1. And I can add on the constant vector or any specific solution, 1, 2, 0. Well, we'll stop there, and next we'll talk about the concept of linear dependence and independence.